Okay, so we've talked about the hazards, we talked about the controller, and now we're going to talk about the camera controller. Uh, this is the camera controller. As you can see, it is pretty lightweight as well. It doesn't do very much because everything's been encapsulated on the buttons. Right, so there were three buttons on the camera screen. One was take a picture, one was use this picture, and the other one was reset picture. So let's go to the take a picture mode button, and let's see what that script does. All right, so this is the see take a picture script. You'll see that it comes down. It's doing what all the other buttons are doing, waiting to attach to the main script on the camera controller. This one also uses mouse down and mouse request and mouse and touch began, and it calls the process request routine. And in the process request routine, what happens is that it calls the audio play clip that says the button's been pressed. It calls this routine called init, which initializes the camera, and it calls take pictures, which goes in and takes the pictures, and it uses this callback function to return the name of the file where the routine put the picture so that you can use the picture and other things. Now, the problem that we ran into is the device camera in Unity 3D with Unity 3D only works with the full Pro active license. That's what all the documentation says. That's what all the experts that have used it said. That's what all the information I got while trolling the internet, trying to find out why I couldn't get it to work. So I couldn't get the camera to work. I did all the proper code, everything's right, but it did nothing. Now, I suspect that even though I'm using the special access code that was given to me by the FSO, the problem here is that it says at the bottom for educational use only. So now I don't know if it actually gave me 100% of all the Pro features. There might still be something that it didn't give me that the license says really is unnecessary. And I suspect that's why I can't get the camera to work using the normal Unity 3D commands. So what I did was I went online and I went to the asset store at Unity 3D to see if anybody made a third party made an add-in that works with Android cameras. So I'm using a Nexus 7 tablet running Android. So I found the pack. I found an add-in by this company. It was called Android Common Functionalities, and I downloaded it. I purchased it. It cost me about $20. And when I installed it and executed the command, that's what Android Commons is. I mean, that's not a Unity 3D thing. That's the third-party add-in company. So when I call this routine, what it does is that it actually gets the camera to work, and the camera's working, and I can see the forward camera, I can see the back camera, I can I can adjust, make corrections for lighting and stuff like that, and I can take pictures or I can take movies. Now the problem is that when I do that, I can't get the file name because the callback function still doesn't. It will not execute. I can't. It's not executing the callback function. So if it doesn't execute the callback function, I can't get the name of the file where they stored the image. So again, I suspect it's the same problem. Because it's not a full active Pro license, there's some capability that isn't set, and that's why it's not working. I find it hard to believe that Unity would allow a third-party vendor to put an add-in into their extremely successful package if it didn't completely work properly. So I have to assume that that's what the problem is. I got a call. I sent them an email trying to find out why, but I suspect that's what's going to happen when it comes back. So right now, the only thing that happens is that the camera comes up. You can see the camera. You can take a picture, and that's it. So I couldn't get anything else to work. So that's what the play camera routine does. All right. Now there's the checkbox option that says that you want to use the picture that you took. So that would be use photo checkbox class. And so you'll see it has the same format, comes in, it checks to see what the player preferences is for the camera label, same custom information that gets added in at the properties level that customizes the script, checks to see if it was selected, and if it is, it says X, and if it's not, it puts it an underscore. It's doing the same thing where it's trying to get the camera controller script to attach to that. This also works on mouse down and touch began. Calls the routine called process request, and it essentially is doing the same thing as it did in the hazards, which is toggling. Okay, and it saves the value, plays the script, and that's what that does. Now there was another one, the other button that was essentially that said it was reset. It was a reset photo so that it uses the default nebular picture as the background. And so we'll see where that button is. And that's what that button is. And what that does is that replaces the file name with the default file name, and it takes the reset button, and what it does is it removes the check, it removes the X from the use picture, and it puts the file name back to the default. Now the picture that you had up there, the custom picture, is not lost. It's still there. The system saves only one picture, and it saves the last picture that was taken. Okay, and that script looks very similar like the rest of them. It's exactly like this. All right, that would be, so as you can see, it looks the same as the other one. It's the reset script. Okay. All right. So that covers the camera. So now what we're going to do is we're going to go look at how the touch works and the acceleration, how it works. And we're also going to talk about the design concept that was used to how we have continuous laser blasts and how the ship moves smoothly and at a continuous speed. So let's go to the player controller. That's the player's ship, and this is the script that's on the player's ship. So it has the same situation where it has to attach to the game controller. Okay, it does all the same stuff, and it comes down and it runs this fire laser bolts routine. The fire laser bolt routine is it has to run concurrently, because the method that what we found out is that when you try to do the touch buttons, there's a certain latency between when the actual event fires and when you actually see a laser bolt fire. So as a person is pressing the button, it's not a consistent flow of laser bolts, and there's a delay, and it doesn't give a nice feel to it. So, because typically somebody wouldn't just sit there and keep on pressing the button, they put their hand on the fire button and they want it to continuously fire. So what I did was I created a fire laser bolt routine that operates on the concept of a shutter. So when you pass the shutter a 1, it opens the shutter and the laser bolts just continue to execute, all right, in a continuous fashion. And if you send it a 0, then the laser bolts will stop happening, and that's how we get the laser bolts to stop and start. Now, when you press down, that sends a 1. When you pick your finger up on the touch ended method, that's where we send a 0. All right, and you can see that from the fire button pressed. So All right, so you'll see on the touch begin, it sends it a 1. All right, fire laser sends it a 1. On touch ended, it sends it a 0. Okay. So now you'll see this thing here called touch stationary. This event has to be used because there's it has to do with when you're dealing with a mouse and a keyboard. The mouse can only touch one thing at a time. So the mouse is hitting the fire button, and you're using the arrow keys to move the device, to move the player ship forward, down, left, and right, and so forth. Now, because this was originally written for a web player, so when you're dealing with the touch buttons in a on a touch screen, you can actually press multiple buttons at the same time. So what happens is that it creates a collection, and then I have to walk through the collection, and then that's what this button touch logic does. Okay, and what it does is that it walks through a collection of all the buttons that have been pressed and executes the events accordingly. All right, now when I press the button, I get one event. If I keep my finger on the button, I still get only one event. Okay? And then when I take my finger off, I get the up event. Now, I want it so that when the button is down, I want an event for as long as the person has his finger. I want an event for as long as the finger is there. So I want continuous events. And that's why I'm looking at the touch stationary. So this, by using that event, I can have both the fire button and the left and right, up and down buttons pressed at the same time, and the ship will move smoothly. It won't be interrupted or jittery or anything else because of how the events are being processed in this collection when it goes through the collection. Right? So that's why the fire button implements the fire button also implements the stationary. And so does the left, right, and up and down buttons. They also implement the stationary. Okay? So that's how things work with the laser. Now, in the player controller script, when we have the ship, when the ship moves, the ship has to move in a continuous fashion at a steady speed. We can't do that if I do all movement when the person presses the button. So when the person presses the button, you want to make it such that as long as the button's down, the ship will move in a steady, continuous speed, at a steady speed, and move in either of the appropriate directions. So the way that's performed is the same concept as the laser. This routine here called move ship is essentially like a pulse engine. And what it does is that it continuously sends pulses to the ship, making it look like it moves continuously. Now, there's a conditional constant that is used that determines whether you go, if the conditional constant is -1, that means that you'll move in either a left direction or a down direction. If the conditional constant is a 1, you will move into the up position or you move in the right direction. If the conditional constant is a 0, now you'll stand still. And that's how this works. So when the person holds the button down, a 1 is sent to the, so if the up button is pressed, a 1 is sent to the engine, is sent to the vertical axis part of the engine. And if I press the down button, a -1 is sent to the vertical part. If I press the left button, a -1 is sent to the horizontal component of the engine. And if I if I press the right button, then a +1 gets sent to the horizontal component of the propulsion engine. All right, and that's what this algorithm does. It handles all of that. So that's how we do the movement, and that's how we get that nice smooth movement as it moves across while the person holds the button down. And it's very natural. You hold the button down and it moves in that direction. Pick your finger up and it stops. Okay? So that's how this engine works. And that's what the push buttons are doing. So to give you an example, if I go to the uh, C down button pressed, okay, you'll see that what it does is that it sends a -1 to the move ship routine. Okay, that's with mouse up, mouse down. But let's look at the touchpad. Touch begin, touch ended. It sends a -1 because this is the down button, and when the person picks up their finger, it sends a 0, which says stop. And this also uses the stationary for the same exact reason. You want continuous pulses sent while the person holds his button down, holds his finger down. You just don't want one pulse sent, one event to happen. You want multiple events to happen. So that's why we're looking at the stationary as well. And that allows the person to hold the fire button down and hold one of the motion keys down at the same time. And the ship will traverse smoothly, and it'll fire the laser and everything it's supposed to do. Okay? So let's look at the accelerometers now. So what we'll do is that we'll go to the player controller, and we'll look at the code that handles the accelerometers. Now, one of the things about the accelerometers, the Nexus 7 has 3 accelerometers. One for the X direction, one for the Y direction, one for the Z direction. Now, because this is a 2D shooter type of game, it's a 2D type of game, we only really care about the X accelerometer and the Y accelerometer. Now, when we're dealing with the X accelerometer, we're dealing with if the pad is tilted to the left or the pad is tilted to the right, the accelerometer would oscillate between -1 and +1 based on the angle of the pitch of your tilting the tablet. Now, because it's very sensitive, this causes a problem when if you consider 0 to be stopped. So what the effect that you see is that the ship is like going back and forth. It's jittery. Sometimes it just takes off, and it's not exactly a good experience in how to use the system. So what we have to do is we have to use a concept called a hysteresis. What that means is that we set a value, a trigger value that's below 0, that's on one side of 0, and we set a trigger value that's on the other, a positive value that's on the other side of 0. Now, as long as the values are between those two trigger points, we will return 0, and that's how we get the ship to stop. If the number exceeds the lowest trigger, then that's how we send a -1, and it'll go to the left. If it's greater than the highest trigger, then we send a 1, and it goes to the right. And it works very well, and it's a very smooth transition of the move. And as you look at the code, you can see that where it's less than the left trigger, -1, greater than the right trigger, +1. Okay. Now the Y accelerometer is exactly like the X accelerometer. The only difference is that because it's the Y direction, the assumption is that 0 is when the tablet is lying flat on a table. Okay? Now, that's not how somebody holds the tablet. The person would hold the tablet up on an angle because that's how they're looking at it, reading it, and using it. So now what happens is that the only values you'll never get a value that's less than 0. It'll always be positive. So you can't use the same concept where you're hovering between +1 and -1. So what you end up doing is you still use the hysteresis. The only difference is that now your trigger is a low plus number, and your upper trigger is a high plus number. So now what that means is that while the values are between those two triggers, the ship will not move, and that's the effect that you want, and the person can read it. So as you can see the code, if you fall below the trigger, the lowest trigger, it'll send a 1 to say you need to move the ship. So if you put it forward, if you lean the tablet forward, it will. If the value is less than the lower trigger, then it sends a +1. It sends a 1. and the ship goes forward, and if it is greater than the higher trigger when you pull it back, then what it does is that it sends a -1 and the ship goes backwards. And that's how the controls work. And I was pretty impressed on how once you use this hysteresis method, it's pretty smooth, and it's just as good, if not better, than the touch controls. So I plan to use both of these and give the user an option that says which one do you prefer. But I actually liked the fact that I just tilt the tablet back and left, right, up and down, and it doesn't give me a cramped feeling by holding the buttons and moving the buttons with my fingers. But that's my preference. Okay, so that covers the user interface, the additions that we made to the Space Patrol program, and hope to talk to you soon on the next project. Thank you.